Here is a question. Read it carefully and think about the answer. Let us solve it step by step. Let us first understand the key concept here. Lindlar's catalyst, Pd-BaSO4 with quinoline, or simply Pd-BaSO4, is a poison partially deactivated palladium catalyst used for the partial hydrogenation of alkynes to alkenes. The key feature of this catalyst is that it delivers hydrogen in a SYN-CIS fashion to the triple bond, and it stops at the alkene stage rather than fully reducing to the alkane. Moving on to the next step. Identify the starting material. 2-butene is CH3CCCH3, an internal alkyne with the triple bond between C2 and C3. Moving on to the next step. Identify the reagent. H2PD-BaSO4 is Lindlar's catalyst, a poisoned palladium catalyst. It performs SYN addition of H2 across the triple bond and does not over-reduce to the alkane. And for the final step, determine stereochemistry. Because H2 is delivered from the same face of the triple bond, SYN addition, both hydrogen atoms add to the same side of the resulting double bond. For an internal alkyne like 2-butene, SYN addition gives the CIS alkene product. Identify the product. SYN addition of H2 to CH3CCCH3 gives CIS, 2-butene, both methyl groups on the same side of the double bond. Why other options fail? B. Trans 2-butene would result from anti-addition, which is characteristic of dissolving metal reductions, example, NaNH3, Birch-type conditions, not Lindlar's catalyst. C. 1-butene would require isomerization of the double bond position, which does not occur under these conditions. D. 2-hydroxybutane would require addition of water, hydration, not H2. Therefore, the correct answer is A. Therefore, the correct answer is option A.